In this lesson, we're going to be taking a look at how to classify polynomials. And so there's some vocabulary involved. And so on this page, you see a definition of what the degree of a polynomial actually is. And then below that, we have this table. And this table is going to be the particularly critical part where you're going to need to be able to look back at that later and be able to tell what name goes with what degree for any given polynomial. So take a moment, go ahead and pause this video and write that down, and then press play again when you're ready to go to the next page. And the other part of classifying polynomials is these definitions. So again, these are going to need to be written down so that you can look back at them and reference them as we go forward. So go ahead and pause the video, write these down, and then press play again when you're ready to go. All right, we're now going to actually apply the notes that you've written down. So first up, when we go to classify a polynomial, we always will first classify it by its degree. Now remember, in your definition that you wrote down, the degree of a polynomial is its highest exponent. And so if I then take a look at number 1 here, I want to see what is the biggest exponent in that particular one. And as I take a look at that, I can see it appears to be the 3. That means that number 1 here is degree 3. The only question then is, what do we call a degree 3 polynomial? And so you look back at your notes, look at your table there, and you see that 3 goes with the name cubic. So we know that that particular polynomial is cubic. The other thing that we need to do is classify it by its number of terms. And so number of terms is basically how many monomials there are. This is from your notes. Another way to look at that is all of the terms are separated by addition and subtraction. In the case of number 1, all we have is just one subtraction in there. And so that means that there's 2 terms in this particular one. Our first term is this 8x cubed, and our second term is the negative 5x. So there are 2 terms. So knowing that there are 2 terms, check out your notes there, and you'll see that if there's 2 terms, we call that a binomial. And so then when we go to classify this completely, then we call it a cubic binomial. So having seen how that was done, take a moment, try to do number 2 on your own before continuing with the video and seeing how I do it. All right, it's always a good idea to be checking yourself. Try it first and then check it. So that's why we want to try doing it on our own first. Let's go ahead and jump into number 2 now. So first thing I need to do is I need to know what its degree is. So that means the highest exponent, and the highest exponent here would be the 2. Okay, so that means it's degree 2, which if you look in your table means that it is quadratic. Then I need to count how many terms are there. And I see 1, 2, 3 terms, because remember the terms are separated by the addition or subtraction symbols. And so if there's 3 terms, then this is not just quadratic, it is a quadratic trinomial. And so that's how we classify it. All right, and then for number 3, before you try to work this one out on your own, there's a little bit of a wrinkle with it. Because if you try doing this one on your own first, you might be inclined to call it a linear trinomial. And the reason why it would be linear is because you'll notice that when we have this 4x here, and we happen to have it twice, that the exponent on 4x would be 1. Because if we don't write an exponent in there, the missing exponent is a 1 there. So that would be degree 1. And you can see that it looks like there's 3 terms, but there's one little wrinkle with this problem. You notice that we do have 4x and minus 4x. Those can combine. Those are like terms. And because every single polynomial, no matter how it's written, should have exactly one classification, we always want to simplify first if we can. And in this case, that means combining the 4x minus 4x, and 4x minus 4x is 0. So that just totally goes away, leaving us only with the negative 7. So -7 is actually what we're going to be classifying here. All right, so then how do I classify -7? Because the first thing we need to know is what's the degree, which is the highest exponent. But I don't even see an x there. How could there be an exponent? Well, if we tried to force putting an x in there, in order for it to not have to be there, it would have to be to the power of 0. And so this is actually a degree 0 polynomial. And if you check your notes, you'll see that degree 0 is called constant. And there's only the one term, and so it's a constant monomial. And now you can see here why then degree 0 is called constant, because no matter what we might try to say that x equals, it's always going to be -7. Well, what if x equals 5? It doesn't matter. The whole thing still just equals -7. It is constant. That is, it's unchanging. It's constant. And it is a monomial. In fact, every time it is constant, it will be a monomial. You can never have a constant binomial, because if you did have a constant binomial, like 5 plus 3 or something like that, you could combine like terms and simplify it first into a constant monomial. So every time it's constant, it will be a monomial. And for that reason, oftentimes you'll see constants only referenced just as constant, and people will often leave out the monomial part. Technically, it is still there, but yes, constant insinuates that it is monomial. When we get down this vocabulary, it's going to allow us to communicate much more clearly about the various polynomials that we talk about during class. And it's also going to help alleviate some confusion, because you'll often hear me talk about how we're going to be multiplying a binomial by a trinomial or something like that. Or we might be getting into quadratics. And I want you to know what we're talking about when we do that. Now, these first three examples should have given you a pretty good grounding about how to go about these problems. So if you feel ready to go do the assignment now, go ahead and go do it. But if you would like a few more extra practice problems, I'm going to go ahead and work a few more here at the end of this lesson that you may choose to watch. All right, so I'm now going to take a look at these three problems, and I'm going to classify each of these three. Just like with that one that I had you do earlier, I would recommend that before I start going through and talking you through how I would get each of these answers, that you actually go through and take a look at each one and try to classify it yourself first. That way you have a basis of operation and something you've already thought through when I start going through it. So go ahead and pause the video and work through that really quick here, and then resume when you're ready. All right, so number 4. The first thing I need is the degree of the polynomial. And it is true that very, very often the highest exponent will be at the start. However, you'll notice that in this particular problem, that's not the case. The highest exponent in this one is actually sitting right here in the middle. The highest exponent is actually a 7. Now, you'll notice in your table there, in your notes, that we don't have anything for degree 7. Yes, there is technically a name, but it's not used commonly enough to be worth memorizing right now. And so when you see that, you can actually just call it a degree 7 polynomial. Okay, so now it's just a question of a degree 7 what? Is it a degree 7 monomial, binomial, trinomial, what? And so we now count the number of terms, remembering that terms are separated by addition and subtraction, which means that I can count 3 terms in that one, which means then that this is going to be a degree 7 trinomial. And then I can go on to number 5. And number 5, I again need to start by figuring out what's the degree, by figuring out what's the highest exponent on any given term, and that's going to be the 3. So this one's degree 3, which we do have a specific name for to know. A degree 3 polynomial is cubic. Okay, so we know it's cubic. Now we need to do the number of terms. So I again just am going to count them up, separated by addition and subtraction, and I see 4 different terms. Okay, well, what do we call it if it has 4 terms? Well, again, we don't have that in our vocabulary. We don't need to use the term quadnomial because it's fairly rare. Once we get above 3 terms, we tend to just say that it's a polynomial of that many terms. So in this case, you would say it is a cubic polynomial of 4 terms. And you can just go ahead and leave it like that when it goes off the table like that. All right, and then finally for number 6. Number 6, did you notice the slight trickiness with number 6? Because in number 6, you notice I have 3x to the 9th, but I also have x to the 9th there. We have some like terms that we can combine. In fact, you'll notice the same thing is happening here with the x to the 5ths. Those are also like terms. So the very first thing you want to do here is simplify. Before you can classify it accurately, you have to simplify by combining like terms. So I'm going to go ahead and do that. The x to the 9ths combine and the x to the 5ths combine, leaving me with negative 4x to the 5th plus 4x squared. Now that I am here, now that it is simplified, I can start worrying about classifying. So first thing I need is my degree. My highest exponent here is 5, so this is degree 5. Therefore, we can know that it is quintic. And how many terms are there? I do count 2 different terms here. Therefore, that is going to be a quintic binomial.